Hello, in this video I will do an A-level math Peer 1 video involving solving quadratic equations by factorization. So yes, this is definitely an A-level math Peer 1 video, and we are solving quadratic equation by factorization. Okay, so before we start, there are some key notes I want you to write down, and yeah, I want you to write this down and kind of listen. So the first keynote is when you're solving quadratic equations by factorization, you're really finding the x-intercepts. So if they ever tell you um, solve solve, they really just mean find the x-intercept. So as you can see in this example, you have a concave up quadratic U-shaped parabola, and your solutions are x equals -1 and x equals -2, which really means your x-intercepts, right? Damn, so great. So you have your solution is x equals -1 and x equals -2. They just mean the x-intercept. So solution means x-intercept. That's all it means. Okay. Another statement, another important keynote is you might not always have an x-intercept. So as you can see, you have this concave up parabola, and as you can see, it doesn't cross the x-axis. This is what's called a vertex, which is basically the lowest or the highest point of a quadratic parabola, right? So later on, you might have let me write this down. There is a way to figure out if you actually have x-intercepts. It's called the discriminant rule. Okay, so there's a little trick because yeah, so basically it's basically this. If it's b squared minus 4ac and it's positive 2, if the outcome is greater than 0, that means you have two x-intercepts. Um, if it's b squared minus 4ac and it's equal to 0, you only have one x-intercepts. And then over here, if it's b squared minus 4ac and it comes out as a negative, you have none. So what you could also have is what's called imaginary roots. In this situation, this would be imaginary, right? Um, but that'll be in another lecture. So yeah, you may not always have an x-intercept. There is one you could figure it out by doing the discriminant rule, b squared minus 4ac. If it comes out greater than 0, you have 2. If it equals to 0, you have 1. If it's negative, you have none. Or technically, it's imaginary, right? So yeah, that's another keynote. Okay, another keynote is when dealing with rational functions in the form of p of x over q of x, to get rid of the denominator, you would have to multiply all sides by the LCD. So yes, this is also important. So when you're dealing with rational functions and you want to get rid of the denominator, the way to do so is you can multiply both sides by the LCD. Um, Now, if you only have two sides, for example, let's say you had, totally making this up, 3 over x equals 5 over 6. So see here we have a rational function because it's in a px over qx form, or it's in a fraction form, and there's only two sides. You have the left and the right. You could just cross multiply. So yeah, I think that would be easier. But if you have more than two sides, for example, if you had 3 over x plus 1 over x plus 1 equals 8, 7, something like this. See how you have three sides? You have this side, this is one side, the second, and the third. You would have to first get rid of the fraction by multiplying all sides by LC. You'll see what I mean when we do some of these examples. But that's a very important keynote. Oh, like I just explained. just like that. So if you have a rational function that only has two sides, you can just cross multiply. So here's a perfect example how this only has a left and a right. Right, this is the left side, this is the right. You only have two sides, right? One, two. So if you have two sides, you could just cross multiply. Okay, so let's start dealing with some examples. So in example one, the direction says solve. So always read the directions. Sometimes they might say solve or factor. There is a difference. So when we solve, our final answer will be x equals a number, right? So let's solve this one. So we have this quadratic parabola. We have 6x squared plus 5 equals 17x. We got to solve, basically find the x step. So what I would do first is make sure you have one side that is zero, one side that has zero. So what I mean is, you see the 17x? Um, I I would best just move it to the left, right? So let's get that to the left by subtracting 17x from both sides. So now we have 6x squared minus 17x plus 5 equals to 0. Okay, then what you want to do is factor. And then once you factor, you just solve. Okay, it's usually those three simple steps. So yeah, how would we factor this? We have 6x squared minus 17x plus 5. So notice how the a value is 6. Um, I do this method. It's called, your teacher might call it different. It's whatever. It's basically the same thing. I call it bottoms up factoring. This only works when the a value is not equal to 1. Okay, so our a value is 6. So how do I do this bottoms up factor? Well, first step is rewrite it as if this 6 does not exist. So it's going to be x squared minus 17x. And then the last term is no longer going to be 5. It's basically a times c, or in our case, 6 times 5, right? So that would be 30. Right? And then from here, it's just simple factoring. You can make your factor tree, but it's just simple factoring, right? You're gonna put an x here, an x there, and then a blank space, and then a blank space. So this is where it can get tricky. What two numbers multiply 30 and when added gives you negative 17? So yeah, what two numbers multiply 30 and when added gives you negative 17? I would say negative 15 and negative 2. So you might not get it quickly. Like it's something you kind of have to like adjust sometimes. But I see that it's negative 15 and negative 2 because what's negative 15 times negative 2? Positive 30. And what happens when you add these two numbers? What's negative 15 plus negative 2? Negative 17. So I'm going to put a negative 15 here and then a negative 2 there. Okay, then continuing up with bottoms up, I'm going to divide the negative 15 and the negative 2 by 6 only. So don't worry about this x. Do not divide x by 6. Divide only the negative 15 and the negative 2 by 6. Okay? Then what you want to do is you don't want it as a fraction. What you want to do is try to reduce it first. So can negative 15 and over negative 15 and 6 be reduced? Yes, by 3, right? So negative 15 divided by 3 is 5. 6 divided by 2 is 3. I mean, 6 divided by 3 is 2. Same thing here. Negative 2 over 6 can be reduced by 2. So this would be 1 over 3 equals 0. Okay, so like I said before, you don't want it as a fraction. So what this is why they call it bottoms up. Bottoms up. So you're going to put the 2 in front of the x and then leave the numerator alone. So it's going to be 2x. Leave the numerator alone, negative 5 alone. And then the same thing with this 1/3. You can't reduce it anymore. So put the 3 in front of the x and then leave the numerator alone. And then last step is solve. So some people could see your two solutions are 5/2 and 1/3. Okay, so if you didn't see it, what I'm doing is literally setting each parentheses to 0 and solve it for x. Okay, so over here I'm gonna have to add 5. 5, you get 2x equals 5, and then divide this by 2. You get x equals 5/2. Same thing here, you're gonna add 1, you're gonna get 3x plus 1, divide this by 3, get x equals 1/3. Okay, so yeah, that's pretty much how I solved for this one. Great, not too bad. You can do this. So yeah, I call this bottoms up. Your teacher might call it something different, but it's been interesting. Okay, let's move on to example two. The direction says solve. We have this quadratic polynomial. We have 9x squared minus 39x minus 30. So the first thing I'm going to check is if this side is 0, it is, so I don't have to move anything around. Um, what should I do? So now I'm going to start factoring. So I technically can do bottoms up. You could also do quadratic formula, but there's also one thing I could also do first. I think everything is divisible by 3, right? So if I divide 9 by 3, that's what I'm going to do. Maybe it'll make your life easier. And then don't forget about the 0. Okay, so 9 divided by 3 is 3. Negative 39 divided by 3 is negative 13x. Negative 30 divided by 3 is negative 10. Okay, now I'm going to continue with bottoms up because my A value is no longer 1, it's 3. So I'm going to try bottoms up. So it's going to be, your first step is rewrite it as this 3 does not exist. And then you're going to multiply 3 times negative 10, which is negative 30. And then factor this out. And you get x, x. And then what two numbers multiply negative 30 and when added gives negative 13, negative 15, and positive 2. Then you're going to divide the negative 15 and 2 by your original A value, 3. So I get negative 15 divided by 3 is negative 5. And then 2/3 is a fraction that cannot be reduced. So you put the 2 in from the x, and then leave the numerator alone. Okay, so when you solve for x minus 5 equals 0. 2x plus 2 equals 0. I would add 5 here, add 5 there, get x plus 5. And then the same thing here, I'm going to subtract 2. Combine this by 2, you get x equals negative. Okay, those are your two solutions. Okay, I'm going to copy that down. I gotta just conceding. Second, go ahead and copy. Okay, I'm back. So let's just move on. Second. So yeah, let's move on. Okay, example 3, the direction says solve, and this time it's a little bit different. We have 3 parts, right? We have rational functions. We have 3 parts. You have the left, the middle, and then the further right. So first thing is what I would do is sorry, I'm gonna get rid of the denominator by multiplying all three sides by LCD, most common denominator, right? LCD. So this is where it can be a little bit tricky. What is my LCD? So look at the bottom or the denominator. Over here we have we have 2x. Over here we have an x plus 3. And then over here there's an invisible 1, right? So what is the else? So the good news is it's already in the most premise form, right? 2x, x plus 3, and 1. It cannot be broken down. So um and they're different bases. This is a base of 2x, this is a base of x plus 3, this is a base of 1. So that's good. So when you're in the most premise form and the bases are all different, you literally just put it all together. So your LCD is 2x times x plus 3. And then you also have that 1, but you don't have to worry about that 1 because 1 times anything is itself. So this is my LCD. Do not FOIL it out. Leave it as it is. Now, if you need a little bit more help on LCD, there is a video on supplementary about how to find LCDs. So yeah, that's basically my LCD. It is 2x parentheses x plus 3. So I'm going to get rid of, I'm going to do all three sides. I'm going to multiply everything by 2x times x plus 3. Okay, so that's a little bit confusing. So let's do the first side. What is this whole thing, 2x times x plus 3 times, I believe that's a 21 over 2x. So you just have to be very neat. There's a little trick that I do. If it is the same on the top and bottom, they cancel. So as you can, if you have to do it one at a time, so for example, 2x times x plus 3 times 21 over 2x. What I do is look at anything that's the same top and bottom, they cancel away. So as you can see, the 2x are the same top and bottom. So cancel, cancel. And then you're just left with 21 and x plus 3. So I'm just going to write that out. So we're left with 21 times x plus 3. Don't FOIL it out yet. Just continue. So that was the first part. Now do the middle part. Be careful, there is a minus. So I'm going to put a little minus in it. I'm going to put a little bracket to distribute that minus. So what is this times this? So if you have to write it out, that's fine. It is 2x times x plus 3 times 2x plus 3. They're this, what do you see that's the same? The x plus 3, that's it. So you're left with 2x times 2. Now do the further right. What is 1 times this whole thing? That is 2x times x plus 3. Okay, now go ahead and FOIL it out, clean it up. So it doesn't matter what you do first. So let's start the right side. I don't know why, it's just easier. What is 2x times x? 2x squared. What is 2x times 3? 6x. And then over here, just be kind of careful. Just, let's see, what's 2 times 2x? That is 4x. And then you have a minus, so that's going to be negative 4x. Over here, FOIL out this one, so that would be 21x. And then 21 times 3 is 63. Okay. Then just like the we have to get one side, whoops, we have to get one side 0. So what would I do? I think I'd move everything to the right. Why would it move everything to the right? You see this power x2, it's the highest. It just stick with the highest power. So this has that power too, and I think it's best to stick on that side. So that's why I'm moving everything to the right. So by the way, before I move things around, can I collect like terms? Yes, I can. What is 21x and negative 4x? It is 17x. And then you saw the 63, right? Now what I'm gonna do is get everything to the right. So I'm gonna subtract 17x, make sure it's aligned with the 6x, and then subtract 63. So you get 0 equals 2x squared with 6 minus 17, negative 11x, and then you have negative 63. Okay, so now we gotta solve. So I'm gonna have to factor this in. Because the a value is 2, we're probably gonna do bottoms up. So how do I do bottoms up? Rewrite it with the as if the 2 doesn't exist. So it's an x squared minus 11x. And then what you do is multiply 2 by the last term. So what's 2 times negative 63? Negative 126. Okay, and then continue. So this is going to be parentheses. So we're going to do simple factoring. So what two numbers multiply negative 126? And it gives you negative 11. I believe it would be negative 18 and 7. So you might have to think about it a while, because yeah, that's what I did when I did. I did have to think about it. So let's see. Does negative 18 times 7 give you negative 126? Yes. Does negative 8 plus 7 gives you negative 11? Yes. So it's going to be negative 18 plus 7. And then what I'm going to do is divide the negative 18 and 7 by your original a value 2. What's negative 18 divided by 2? Negative 9. And then 7/2 is a fraction that cannot be reduced. So you put the 2 in front of the x. So that's 2x plus 7. Okay, when you actually solve for it, you're going to get positive 9 and negative 7/2. Okay, there's your answer. Let's do example 4. So the direction says in example 4, solve. We have 3x squared plus 26x plus 35 all over x squared plus 8 equals to 0, or 0 can also be expressed as 0 over 1, right? It's not the same thing as 1 over 0 because that would be undefined. So I could put a 1 here if you want. Now, the good news about this one is there's only two sides. You have the left and the right. So what you could do is cross multiply. So you don't have to get rid of the else. You could multiply both sides by the LCD. That's perfectly fine. But you can also cross multiply. So and that's what I'm going to do. So what's 1 times this whole thing? It's just itself. And then what is x squared plus 8 times 0? 0. Anything times 0 is 0. Okay, so what I'll do next is, hey, could I divide everything by 3? Because I don't like this 3. I think I could. I could divide everything by 3. That'll make your life so much easier. Don't forget the 0. So over here, this is going to be x squared. And then over here, where's my cursor? What's 26x over 3? Uh, oh, actually, I take that back, 35. This doesn't come out nicely. So, yeah, I take that back. So forget about that. So we just have to continue bottoms up. So I'm going to do bottoms up. So it's going to be written as x squared plus 26x. And I'm going to multiply 3 by 35, which is 105. And then factor this out. So what two numbers multiply 105 and then when gives it 20, added gives it 26. Um, Let me try 21 times 5. So what is 21 times 5? 105. What is 21 plus 5? 26. So bingo, that works, right? So it's going to be x, and plus 21, and then positive 5. Okay, so then continue. Remember with bottoms up, you're going to divide 21 and 5 by your original a value, right? 3. Uh, what is 21 divided by 3? 7. Now, 5/3 is a fraction. I don't like fractions. Now, can 5/3 be reduced? No, it cannot. So what you're going to do is put the 3 in front of the x. And leave the numerator. Okay, so when you actually solve for it, you're going to get x equals -7, and then x equals -5/3. So if you're curious how I did that, I basically set each parenthesis at 0 and solve for x. So that's what I got. Okay, example 5 is a word problem. A rectangle has sides length of x and 6x minus 7 centimeters. The area of the rectangle is 90 centimeters squared. Find the length of the rectangle. So yeah, so what I would do is draw an image. So imagine we have a rectangle like this. And they're saying that the length is exactly 6x x 7. The width, they said, is just x. So we gotta find the actual length. So what did the else did it tell us? The area of the rectangle is 90 centimeters squared. So what is area? Area is basically length times width. And I'm going to replace my area with 90. And I'm going to replace my length with 6x minus 7. And I'm going to replace my w with x. So this is going to be 6x times x, that's 6x squared. And then -7 times x is -7x. Okay. So now we got to solve. So we got to factor. So what do we have to do is get one side 0. So I'm going to subtract 90 from both sides. Okay, so I get 0 equals to 6x squared minus 7x minus 8. Okay, and now what I'm going to do is, can I divide everything by, no, not 6 or 3. I'm just going to have to do bottoms up, right? So it's going to be 0, and then it's going to be x squared minus 7x. And then you're going to multiply 6 by -90, it leaves -540. Mhm. Do this one. Okay, so what two numbers multiply to give you -540 and now I'm adding gives you -7? I believe it would be -27 and 20, right? Because that multiplies gives you -540 and -27 plus 20. It's -7. So that's what. Okay. So remember with bottoms up, then what you have to do is divide the -27 and the 20 by original a value, which was 6. And then what you want to do is try to reduce as much as you can. So this 27 over 6 can be reduced, yeah, by I believe 3. So that would be -9. 6 divided by 3 is 2. The same thing here, 20 over 6 can be reduced by 2. So 20 divided by 2 is 10. 6 divided by 2 is 3. Okay. Oops. And then what you're going to do is you don't want it as a fraction, so you put the 2 in front of the x and then leave the numerator alone. Something here, put 3 in front of the x and then leave the 10th numerator alone. Okay. And then when you actually solve for it, you are going to get x equals 9/2, and or yeah, 9/2, and then over here, I don't think we could ever use this one, um, because this will give you a negative length, right? 3x plus 10 equals to 0. Subtract 10, get 3x equals -10 divided by 3. So this can't work because you can never have a negative length. So x equal, we'll use this, but this is not our answer. It just tells us what x is. So what they're asking is the actual length and the width, right? So we found our x, so we could say that, what is it? So length is, you can call our length is 6x minus 7. So all you gotta do is replace x with 9/2. So 6 times 9/2 minus 7. And what's 6 times 9/2? So that's gonna be 27 minus 7. 27 minus 7 is 20. Okay, and then my width is just x, so our width is going to be 9/2. Okay, good. Does that make sense? O- Okay, let's move on to example 6. So example 6 said there's an A through F, so that's how many parts? One, two, three, and six. There's 6 parts on the example 6, and the direction says solve by factorization. So we got to solve. So let's look at A. We have x squared plus 3x minus 10. Oh, this is not too bad. First step is I realized the right is 0, so that's good. We don't have to do that. Yeah. So write out in 2 parentheses, and then print x here, x there, and then blank space, blank space. So we're going to do regular simple factoring. So what two numbers multiply -10 and when I add it gives you 3? I think we'll be just 5 and wait. Yeah, I'm going to do 5 and I'm going to use -2 because 5 times -2 is -10. Add these 5 plus -2 is 3, positive 3. So yeah, that works, right? So I'm going to do a +5 and then -2. But can we leave our answer like this? No, they says solve. So when I solve for it, I am going to get x equals -5 and x equals +2. Okay, does that make sense? So what I'm really doing is after I set the parentheses, I'm literally setting each parentheses to 0, but I'm kind of like doing it in my head, right? Okay, so we did that one. Let's do B. We have to solve, we have x squared minus 7x plus 12. The good news is one side is 0, so I can just continue, start it by factoring it out. And it's just regular simple factoring because the a value is 1. So I'm going to put a blank space here, a blank space there. So can you come up with two numbers multiply 12 and add gives a -7. Yes, it would be -4 and -3, right? It's -4 times -3 is +12, and then -4 plus -3 is -7. So when I solve for it, I get 4 and +3. Let's do C. So we have x squared minus 6x minus 16. So it's really just simple factoring. So write out your two parentheses. Put an x here, x there, and blank space. So what two numbers multiply -16 and when added gives a -6? I believe it's -8, +2, because -8 times +2 is -16. -8 plus 2 is -6. You know, they both satisfy both conditions. Okay, so they want me to solve for it. So when I actually solve for it, I'm going to get +8 and -2. Okay, let's do D. So D, we have 5x squared plus 19x plus 12. The first thing I checked is one side is 0, so that's good. And how am I going to factor this? Well, the A value is not 1, it's 5. And I don't think I could divide anything. I don't think I could divide anything out or take out. So I'm just going to do bottoms up. Okay, so first step is we wrote it as if the flaps is opposites. Then we're going to multiply A times C over the first term times the last term. So what's 5 times 12? 60. And then from here, we're just going to do simple factoring. So what two numbers multiply 60 and add it gives you positive 19. I believe it will be 15 and 4 because 15 times 4 is 60. And then what's 15 plus 4? Positive 19. Okay, good. That's what I want. So write out my parentheses. Said it was positive and positive. Okay, so then what we do is divide the 15 and the 4 by 5, right? Nowhere else. Okay, so over here, I'm going to try to reduce. So 15 divided by 5 comes out nicely as 3. And then 4/5 cannot be, doesn't go away, and then it can't be reduced. So what you're going to do is put the 5 in front of the x, and then leave the parallel. Okay, so when you actually solve for it, you're going to get x equals -3 and x equals -4/5. Yeah, -4. Yeah, negative. Oh. So those are my two solutions. Okay, what about E? So E, we have 20 minus 7x equals 7x squared plus 7x minus 20. The first thing I'm going to do is make sure there's one side that's equal to 0. So I think it's wise to move everything to the right. So I'm going to add 7x here, add 7x there, and then I'm going to subtract 20. Subtract 20. So I get 0 equals 6x squared, and then 7x plus 7x is 14x. Oops, I made a mistake. There should be, this was an additional negative 20, so it's really, yeah, this is going to be negative 20, so it's going to be 6x squared plus 7x. Yeah, I'm sorry, so dumb. This was not here. It was when I was doing the problem, I wrote it extra in my notes. So there should be no 7x and negative 20. But this is right, so I would have to subtract 20 and add 7x. So this is going to be 7x minus 20. Okay, so what would I do next? I would definitely do bottoms up because a value is 6. It's going to be x squared plus 7x. And then 7 times negative 20 is 120. Okay, from here on, we're just going to do simple factoring. Next here, go next there. When two numbers multiply negative 120 and add gives us 7. I will definitely use 15 and negative 8. Because 15 times negative 8 is negative 120. And then 15 plus negative 8 is always 7. Plus 15 and then negative 8 there. Okay, so then what I'm going to do is divide this 15 and negative 8 by original a value, 6. Okay, so 15 over 6 will be reduced by 3, right? So 15 divided by 3 is 5. Right, so I'm trying to reduce, I think 15 and 6 can be reduced by 3, so 15 divided by 3 is 5. 6 divided by 3 is 2. And then the same thing with 8, 6. 8, 6 can be reduced by 2. So 8 divided by 2 is 4. 6 divided by 2 is 3. Okay, so when we solve for it, we're going to get, or continue with bottoms up. So over here, you can put the 2 in front of the x, so it's 2x, and then leave the numerator alone. Here, the same thing here, 4/3 cannot be reduced, so you put the 3 in front of the x, and then leave the numerator alone, just like that. And when we solve for it, our two solutions are negative 5/2 and negative 4/3. And those are my two solutions. Okay, letter F, we have x times 10x minus 13 equals 3. So the first thing I'm going to do is FOIL the left side. So FOIL this out. Wow. Okay, so go FOIL this out. What's x times 10x? It is 10x squared. What's x times negative 13? Negative 13x equals 3. And then what I would do is get one side 0, so I'm going to subtract 3 for both sides. So I get 10x squared minus 13x minus 3 equals 0. Okay, then I'm going to do bottoms up, but first can I divide by number? No, so that 13. So go ahead and continue with bottoms up. So it's going to be x squared minus 13x, and then 10 times negative 3 is. Okay, then factor this out and see. So put an x here, x there, and then blank space, space. So in your head, can you come up with two numbers on multiply negative 30, and when added gives you negative 13? Yes, it would be negative 15 times positive 2 because that gives, when I multiply that, it gives you negative 30. And then negative 15 plus 2 is negative 13. Good. Okay, and then what we're going to do next is divide only the negative 15 equal 2 by your original a value 10. Okay. Can negative 15 over 10 be reduced? Yes, by 5. So this is going to be negative 3 over 2. And then can 2/10 be reduced? Yes, by 2. So this would be 1/5. And then over here, what you want to do is put the 2 in front of the x. That's 2x plus 3. And then over here, we put the 5 in front of the x. That's 5x plus 1. Okay, so when you actually solve for it, you're going to get positive 3 halves and x equals negative 1/5. Um, I am going to stop here. I'll make this into a two-part video. Yeah, I'm going to stop right here.